Hi, and welcome to the Virtual Technology Summit. This is Relational to Json with Node.js. Just a quick reminder here, I don't intend to show you anything you can't already do, but in case I slip, maybe mention something that may happen in the future, please do not make any purchasing decisions based on this presentation. My name is Dan McGann. I'm an Oracle developer advocate that focuses on JavaScript and HTML5. My contact info is on screen, so if you want to reach out to me either with questions from this presentation or maybe other related topics, JavaScript and Oracle, any of that kind of stuff, I'd love to hear from you, so feel free to reach out. Also, I should mention that this presentation has been recorded so that we can rerun it in multiple time zones. That also allows us to concentrate on answering questions. So if you have any questions while we go, please feel free to ask. Here's an overview of the agenda. I'm going to start off by talking about relational data versus JSON. We'll compare those two and see what they're good for. We'll also then look at Node.js and the Oracle database driver for Node.js, just some background info on those two components. And then finally, in the third part, I'll go into some detail about converting relational to JSON, relational data to JSON. I'll actually show you some examples of doing that. So the relational model, which is used by relational database management systems, is actually based on mathematical logic and set theory. It's kind of hard to work around math. We have some concepts like relations and tuples in the theory, and they've been implemented in databases as tables and rows. In these systems, we use normalization to eliminate redundant data as well as avoid different kinds of DML anomalies that may occur otherwise, and also to maximize flexibility, preventing database redesigns. Let's imagine for a moment some tasks, if you will. And at first, this list may appear just fine, but upon closer inspection, we might notice some problems. To start with, we have a couple columns here doing double duty. And what I mean by that is they're not holding a single piece of information, but rather multiple pieces of information. This may be easy enough for a human to parse and work with, but it makes it difficult to create applications and automate processes that may be working with this data. In addition, we have what's known as an update anomaly, meaning that if we wanted to update the name of a project, we'd have to be very careful that we update all the different tasks that have that project, or we'd end up with an inconsistent view of the data. This problem really results from the fact that we're actually displaying multiple different entities within this list of tasks. We of course have the tasks and their related attributes, but we're also viewing project-related attributes as well as attributes related to people. In a relational database management system, these would all be broken up into separate entities or tables, and then we'd add various columns to establish relationships back to other entities. So in the case of tasks relating to projects, we'd have a foreign key column where we could establish that relationship. In this case, each task has one project, and each project has 0 or more tasks. In the case of people, to establish the view we saw before where there were 2 people related to a task, we could use 2 foreign key columns, as you see here, or a more flexible model that would allow for any number of these relationships would be to use a lookup table or an intersect table, as you see here. This is much more flexible and could be used to establish a many-to-many relationship. So many tasks could be assigned to many people, and of course many people could be assigned many tasks. This is really the process of normalization, something DBA may spend a lot of time doing. It's advantageous because we can use it to eliminate, for example, the update anomaly you saw a moment ago. Now there's just a single row for each project in the projects table, and so we only have one place to go and make that update if we need to. The real power of this model becomes more obvious when we go to query data back out of our tables. And for that, we use the structured query language, which is abbreviated to SQL, which is often pronounced SQL. So you see here, I have a very basic SQL query. I'm just selecting a few of the properties from the tasks table, and we can see that at the bottom. Of course, it's important to be able to include related entities, and we can do that using a join. So now I'm joining projects, and I'm using the foreign key relationship to do that, and that allows me to then include attributes from the project table. Of course, if we want to get all the way back to the original report we started with, we could use some more complex SQL, including the listag function. So here I've joined in people going through that person task lookup table, and then we can use listag to sort of concatenate the data into a single column as we saw it before, which is a pretty neat trick, right? Now, if you try explaining all of that to a front-end developer, invariably you'll learn that they don't really care. And it's not necessarily a bad thing, it's just that front-end developers have a different focus. They're looking at different things than back-end developers are. So they're focused more on the presentation of the data, right? Whether that's in a grid or maybe a chart or in a form, and how to make all that work. So what they really want is data that's conducive to the environments and languages that they're working in, and that's where JSON comes in. JSON is short for JavaScript Object Notation. It has its roots in the JavaScript programming language. That is, it came from JavaScript, although at this point it's considered a language agnostic data interchange format. It's often said it's a bit like XML light, if you will. It's really based on two structures, and these are going to be at the root of any valid JSON document. You're always going to start with either an object or an array. An object is really just a set of key value pairs, the key being a simple string, the value being any one of these. We have string, number, boolean, or null. Another type of value is structure, so it could be an object or an array, and that's how we end up with recursive JSON. So going back to our tasks table, if you will, if you were to imagine this as JSON, you might see it like this. And you can tell we have an array. If you look at the very top and the bottom here, you'll see those brackets that indicates we have an array. And this is an array of objects. If you see the ellipse at the bottom, that's just indicating that normally we would see more of these objects repeating. Here we're really just looking at a single object, which represents, in this case, a task. As I mentioned, objects are just sets of key value pairs. So you see those keys on the left here. The keys are followed by a colon, and then to the right of the colon you see the value portion. And in our example, ID and budget are both numbers, whereas everything else is really just a string. Now, the reason that front-end developers want to work with JSON is that their language supports JSON natively. So in this case, we're looking at some JavaScript code. I start by declaring a variable called tasks, and then I assign tasks the result of calling json.parse. In JavaScript, JSON is a global object with methods like parse and stringify, which are opposites of each other. So I can use json.parse and pass in some JSON data there, and after that, tasks will be a normal JavaScript array of objects. It's in memory and ready to go. So immediately thereafter, I can start to use it to do work like iterate over each element and then do something awesome with each task. A couple other notes on JSON. Despite its upfront simplicity, there are some gotchas. So the first one is that JSON is schemaless, and you're seeing an example here of an array where the first element is a string, the next a number, followed by an array, and then an object. This is perfectly valid in JSON, and that's not necessarily a bad thing. It certainly lends itself to some flexibility when needed, but it's something to be aware of and to plan for. Next, you see that there is no standard for handling dates, and this is a real bummer because it forces people to kind of invent their own dates, and you have to use data types that we do have available to do so, so either a string or number. Oftentimes when using string, folks use ISO 8601. That's the format I recommend folks use. Over epoch time, which is the number when you see at the bottom, that's the number of milliseconds since 1970. And really the only reason I recommend ISO 8601 is that it's human readable. If you do decide to use ISO 8601, just note that Z at the end there, that's for Zulu, which is kind of the same as GMT or UTC. So if you're not capturing dates in that time zone, just be aware that you may need to do some date time conversion as you're converting your data to JSON data. So, relational or JSON? Which one do you want to use? Well, in a perfect world, we'd use both, right? And actually, that's not so terribly hard to do. And that's what we'll be focusing on in the remainder of this talk. Next up, we'll talk about Node.js and the Oracle database driver for Node.js. What exactly is Node.js? It's basically a JavaScript development platform. It's built on top of Google's V8 JavaScript engine. That's the same JavaScript engine you may be using in the Chrome web browser. It was basically plugged out of the browser and plugged into the server, allowing developers to execute JavaScript code on the server. Prior to Node, for the most part, JavaScript was really confined to only being run in JavaScript browsers. But now folks can take that knowledge and use it in new and exciting ways. One of the more common ways is to create web servers. I'll show you just how easy it is to create a web server with Node.js. But really, Node has all kinds of modules built in for things like HTTP communication, file system access, even encryption and compression, and a lot more. And if there's something you need to do that's not in one of the core modules, then you'll probably find it in NPM or the Node Package Manager. NPM is basically like Yum, if you're familiar with Yum at the command line in Linux. It allows you to install and manage dependencies using a command line interface for Node. There's currently around 240,000 packages available in NPM, and I'm not saying that all packages are created equal, but there are some really great packages in there that allow you to do things like create web servers, connected databases, generate documents like PDFs. Really, anything you can imagine, there's probably a package in NPM for that already. Let's take a look at a simple web server demonstration. So in this one, we'll just connect a web browser to Node over HTTP. And the way we do this is using Express. There are core lower level modules that we could use, but really most folks use Express. So the first thing you'd have to do is install Express using npm, but then you can use it by requiring it in and assigning that to a local variable, like Express in this case. I can then invoke Express and use the result, which I'll store in app, as a web server. Here I'm telling the web server to take any traffic on the route path and invoke my callback function here. And you can see that callback function is given the request as well as the response object. And I'm using the response object to send out hello world to any clients. Finally, we can start the web server by telling it to listen on a specific port, and once it's listening, it'll invoke that callback function you see there just to let us know that it is in fact running. If we then point our browser to Node.js, the response it gives us is hello world. Don't believe me? I thought you might not. So let's take a look at this one. I'll show you. So I'm going to open up a web browser and show you that right now nothing's working on localhost 3000. So in the command line here, I'm going to cd into a web server demo, and I'll show you that right now I just have one file, app.js. And if I cat that out, it's exactly what I just showed you in the slide. So what I'll do now is show you that I have Node installed. If I just run Node, I can do simple expressions like this. But we'll exit out of Node, and this time I'm going to pass Node a file name. And when we hit enter, we see that it cannot find the module Express. So that's a problem, and that's because I have not yet installed it using npm. So I'll do npm install express, enter, And you can see it's there now. If I do another ls, you'll see something new. This is the node modules. That's where they go when npm brings them in. But now I can go back to node space app.js. We run it, and now we have, at least theoretically, a web server running on localhost port 3000. So we come back here, refresh, and it works. See how easy that is with Node? Of course, things get more interesting when we hook Node up to the database because, well, that's where all the data is. And for that, we have the Node.js driver for Oracle Database. This driver currently is at version 1.6. It's got a pretty good release cadence at this point. It's fairly mature. And it has a number of classes out of the box that you'll need to learn to work with. The first of which is Oracle DB. This is the base class. Typically, you're just setting various configuration parameters with this class, but then you'll use it to create either a pool or a connection. You want to create a pool if, well, for example, you have a web server where you have a large number of users and you don't want to have that same number of connections to the database. So you can create a connection pool to service a larger number of users. If, however, what you're doing is kind of a one-off script, you don't need a pool, you can certainly skip that and just go right down and create a connection from the base class. Once you get a connection instance, that's what you'll use to actually execute your SQL and PL SQL code. Of course, as you'd expect, bind variables are supported. And when you, for example, execute a SQL query, the data comes back actually as native JavaScript data types, so you don't have to worry about data type conversion. That's handled for you. Of course, you also have transaction management. There is commit and rollback and all the normal stuff you'd expect with working with Oracle Database. Sometimes you might be working with a table with a lot of rows and you want to read consistent view of that data, but it's not really feasible to ingest all that data into the middle tier, into Node. And so for that, we have a result set, which allows you to fetch a number of rows, a subset of the available rows, and then paginate through the rest of the rows in the result set. And we also have a lob object, which is in Node, it's an implementation of a stream in Node. And so you can stream large objects. You can imagine photos or even video from the client through Node and then directly into the database. And of course, you can go the opposite direction as well using the lob objects. What I have here is some sample code that demonstrates how one might use the database driver within Node. Like before, we start with require, just requiring in the module so that we can use it. And actually, that's not the whole story. You actually do have to have the instant client or a local database installed first. And if you go to the GitHub page for this driver, you'll find some really great installation instructions for that, whether it's Mac, Linux, Windows, we got you covered. So once you get that installed, then you can npm install the Oracle Database driver, and then you can require it in. As before, I'm using Express to create a web server, this time the get method, so that if a get request comes in on /API/employees, my callback function will be invoked. And here, I'm using the base class to get a connection directly. Note that I'm not creating a connection pool. This is just a simple demo, but normally within a web server, you would want a connection pool. And you can see I'm passing in two parameters to get connection. The first of which is an object that has the various properties necessary for Oracle to make a connection to the database. And the second parameter is a callback function, which when invoked in the future, once the database has the connection, it will be passed the connection object. We can then use the connection object to execute a SQL query. In this case, just a select star from employees. And really, I don't need that second parameter there, but that's where you would normally put any bind variables you would have. There's an additional parameter if necessary for some options. And finally, the last parameter is the function, which will be executed when the query is done and you have your results. So in this case, you can see I'm using response.send to send out the rows from the result. Now, in this particular case, I don't have a demo of that code specifically, but in the next part of this talk, I'll show you several examples of converting relational data to JSON as we work to refine a solution for that. But before we get started writing code, we need to define the goal. And the goal in this case is going to be to convert the entire HR schema into JSON. Hopefully everyone here is familiar with the HR schema. If you're not, it's one of several schemas that's included with Oracle database for learning purposes. And as you can see, it's fairly normalized. In the center, we have the main two tables, departments and employees. On the right-hand side, you can see locations, countries, and regions, and those are really related to departments. While on the left-hand side, you can see job history and jobs, which of course are really mostly related to employees. Now, if you want to convert that entire schema into JSON, you're going to have to pick a starting point. So one starting point might be employees, and you can imagine an array of employees where there's a property or an array of job history, and then a property of the department for that employee. Another way you could work your way down is to start with departments. And so here you'd have an array of departments. They would have a location property. Each would also have an array of employees. I thought this particular model made more sense, so that's the one we're going to go with. And at the end of the day, the JSON we're trying to create will look something like this. So the idea is we'll create a function in Node to where we pass in an ID. In this case, it's department ID 10, and we'll get back the JSON representation of that particular department in the HR schema. All right, so for this first iteration, I'm just going to use the database driver in a very simple fashion. So I'll take in my function, I'll take in the department ID, and I will start executing queries against the database to get various data related to that department, and I'll build a large JavaScript object, which at the very end I'll serialize into JSON and return that back out. Now for this to work, I need to turn on my VM here. And by the way, I'll just show you really quick. If you Google Oracle VMs with the S, not sure why that's really necessary. This first hit you get here, that's not a paid hit, will be the one you're looking for. If you click that, you'll see you have access to a number of pre-built developer VMs that are great for learning. You don't have to worry about installing the database or other tooling. It's just there and gets you going real fast. The one I'm using is this database app development VM. This is a great VM. Another one I often recommend to folks is the Oracle Big Data Lite, but take a look at those when you get a chance. So our VM's up and running. What I'm going to do is go to NetBeans, and I have the first solution loaded here. You can see I have solutions 1 through 5 and test 1 through 5. And the only difference between these tests is which solution file they load in, but I'll talk about that in a little bit. So let's go through the first solution. As you can see, I bring in the driver, as we saw before. I'm also bringing in a module called async, which helps you deal with the asynchronous flow and nature in Node.js. Basically, anytime you're doing anything involving I/O, whether it's reading a file or querying a database, you'll be dealing with the asynchronous flow, and async is a great tool to help with that. You also see I'm using a very simple date format here that's really just meant to be used as a string. All right, so we get into our main function. If I scroll past that function, actually, you'll notice that this is the only function that gets exported from this module. So getDepartment is the function that's meant to be called from the outside. And you see that it's taking in a department ID, and we also take in a callback that will invoke when our JSON is ready, and we'll pass that JSON to the callback. So within our getDepartment, we use the driver to get a connection, and there's our connect details. And once we have the connection, we can use that to execute a query. And you see I'm actually making use of the bind variables here, so we're passing in the bind variable for this particular department. And then we get the results, and now I'm declaring a variable named department, and I'm using the results to set various properties on the department object. And once that's ready, I then invoke get location details, and now I'm passing along the department ID, the department object, the connection, and the callback. Sorry, that's actually the location ID rather. So get location details is then called, and that's defined down here. So you can see we're then executing a query going after location data, passing in the correct bind variables, and we get the results from that. And then I append on a new location property, and then I use the results to populate the attributes of that object. So we have department.location.id and so on. So next I go after the country details, passing in the country ID as well as the department, the connection, and the callback again. So we come down here to get country details, and you can imagine it's just doing the same thing, right? We're starting to see a pattern. So now we query the countries table, we get the results, we add a country property to location, and then we take those results and add the various properties we want from them. Then we go and we call manager details. So we're done with department.location. We're moving on to department.manager. So we invoke get manager details, query employees going after the manager ID, and then we add a department.manager property and populate that if we in fact got a hit. Not all departments in HR do have managers. So next we can call get manager job details, and of course this queries the job table using the manager's job ID, and then populates the manager's job object. Finally, we call get employees, and get employees will of course execute a query against the employees table for that particular department. Then we take the department and we add a new employees array. And this is interesting. Now we're looping through the results, which has a rows property. We're going through each iteration there, and we declare a new employee object, and we populate it, and then we push it into our employees array. And finally, I'm using async series for this, I need to go over each employee that we have in our employees array, and I need to get their job history. So that's what we're doing here. We get all the job history, which is an array, and then we push the job history into the array and execute a callback here, at the very end of which we're good. We have our object in its entirety, department in its entirety. And so the very last thing we do is invoke that original callback that was passed at the very top in get department, and we pass it the result of calling Json stringify on the department object. So that's all the logic. And what I'm going to do is open this sources directory in a terminal where I can run the test for this first one. So we run that, and it's starting. So I'll tell you a little bit about this test. Basically, there are 27 departments in the HR schema, and each one of these little ticks here, we're basically we've run get department JSON once for each 27 departments. I set this up to run a total of 100 times, so about 2,700 total invocations of the function, and we don't even have to let it complete. Once we get about halfway here to 50, we know how long that would have taken. We'll just double up. So this is about 33 seconds. It would have taken a little over a minute to finish that. So that is solution one. You can see it's not the most performant solution, but we'll see if we can address that with our next solution. So in this next solution, I'm only going to make one change. I'm just going to start to use a connection pool instead of getting a connection from the base class. And remember, there is some overhead associated with getting a connection. And so if we're getting a connection for each invocation of get department, then that's going to add up. So I want to reduce that overhead as much as possible, and so we'll use a connection pool to do that. Let's take a look at this solution. So here's our first solution, we scroll up to the top of that and to the top of the next solution, you'll notice really that the only difference between them is that first line, obviously, where I'm replacing the base class with this new pool class. And it's actually a pool module, and I've defined that in pool.js. So if we open that up, you'll see it's actually quite basic. I'm using the base class to create a pool, and I do store that pool and also export a get pool function that just returns the pool itself. So that's really all pool.js is, and you can see I'm using it here. I get the pool, and then I get the connection from that pool rather than from the base class as you saw previously. Everything else is exactly the same. So let's see what happens when we run test 2. Oh yeah, now we're talking. In fact, I'll let this one finish, but it should be quite clear that just switching to a connection pool drastically improved performance. We went from about 63 seconds to about 6.3, so you can see very little effort for a big boost in performance. We're not going to get that same boost as we move through other iterations, but it's certainly nice to see that one. All right, let's take a look at take 3. In solutions 1 and 2, well, because they're the same, save the connection pool, we fell victim to joining data in the middle tier, which is actually quite common when folks are new to databases. And we can really fix that situation by doing joins in SQL. This is really a strength of relational database management systems, so we really couldn't do it any better. And ultimately the goal, though, the performance saving comes from reduced trips to and from the middle tier in the database. If we were to visualize how this would currently work, a single invocation of getDepartment would need to execute 7 queries to and from Oracle. We want to get that down to a total of 3, which should have a nice increase in performance. Maybe not as good as pools, but we'll see. We'll take a look. This is solution 2. If you remember, we're going against first departments, and then locations, and then countries, and so on. With solution 3, we turn that on its head, and now we use connection.execute to execute a much larger query, but we can get a lot more data in one shot. So we're getting departments, locations, and countries, as well as employees and jobs, so that we have that manager data right there. And then, of course, the logic had to change accordingly now that we're bringing in the data in a different order. So you'll see that reflected in the code. So that's one query. If I scroll down a little bit more, we'll see another query for employees. And then there's one last query for the job history. And then finally, because we're bringing things in unique order, there's a wrap-up function where we do some last-minute putting things together before ultimately stringifying out our department. So if we run this, let's see if that helps any. All right, so that finished in 2.6 seconds. And if I scroll back to our previous solution, this one finished in 6.3 seconds, almost 6.4. So really nice, almost a little bit more than a 50% drop in time. So again, really nice benefit with just using SQL joins, utilizing a relational database management system to do the joins for us. Sounds like a good idea to me, and it looks like it yielded a nice benefit. All right. Oops. One last improvement. Take 4 is all about executing and doing work in parallel. If you recall in take 3, we reduced the number of round trips to and from the database, but each execute still waits for the previous execute to finish before it goes. And this is just the way it works with database drivers and connections. The connection object acts as a serialization device. And a lot of the time, this is exactly what you want. In for example, the case of a transaction, you need to complete your transaction and commit your work before others can see the difference, right? Well, sometimes there are some edge cases where maybe it's okay to just execute queries in parallel, even if they don't have the same kind of read consistency. And I thought, hey, it's worth giving a shot, see if we can get a performance boost from that. So this is what that solution looks like. So here's solution 3. Solution 4, by the way, is not node related so much. This is a call. You can see it's drastically reduced in size because instead of doing the work in Node, I'm actually calling a PL/SQL function that returns the JSON. So all that logic's been moved to PL/SQL. That's using Apex JSON, which is a great API that came out of Apex 5. So if you're interested in that, I'll put a link up at the last slide that points to a blog post where I covered these topics in more depth. So feel free to have a look at that. But for now, we'll just get that out of here. So really, we're looking at this solution 5 here. And so what I'm doing, I'm using async parallel method to execute several functions in parallel. And you'll see that this is an array of functions. And in each function, I'm using pool.getPool.getConnection. So each function being run in parallel has to get its own connection for this to work. And if we follow this array down, you'll see we pass one giant function. We get to this second one. So this is the second function we're running in parallel. This is the one that gets the employees. And we can run the third query in parallel too. This is the one getting the job history. And when all 3 of those functions finish, then our final function can run to do any last minute tidying up before we ultimately return the JSON. And the way that async parallel knows when all 3 functions have finished is that it passes a callback function which it expects us to then invoke when the function is finished doing any async processing. So that's the way that that one works, and we'll give this one a shot. This is test 5. So we're going against 2.6 seconds. And we got it down to 2.4. You can see not a huge improvement in performance, but it may be sufficient to justify it. Just keep in mind that caveat with the transactions, as that could come back to haunt you. All right. So in summary, the relational model may often be the best way to store and retrieve data, but a lot of folks are going to want that data in JSON format. Luckily, there's lots of tools to convert to and from, and Node.js is an excellent option to do just that. But developers should still take the time to learn about the databases they're working with in order to maximize performance. I have a couple of next steps listed here. If you're interested in learning more about the Node.js driver for Oracle database, do visit the GitHub page. It's action-packed with documentation. Also, if you're interested in learning more about this topic, relational to JSON, head over to my blog where I have a series on just that. Thank you all very much. We'll open it up for Q&A. Thanks again. But wait, there's more. In the post-editing process, which is where I delete some of the mistakes that I made, I realized that I have a few extra minutes to use, and so I thought I would use it harping on an issue I brought up before but didn't dive very deeply into, which has to do with time zone conversion issues. So keeping in mind that oftentimes we're sending JSON down to browsers, this is something you'll want to watch out for, as browsers often convert ISO date formats as though they were GMT or UTC, even if that Z for Zulu is not included on the end. Let me show you what I mean here. So if you remember before, I showed you a date format for ISO 8601, and it had that Z. What I'm going to do is copy this out of here and take it into Google Chrome. And so here I'm in the Chrome web browser, the developer tools, and so I can just say, for example, new date, right? And so we get a date, and note that it's always local time. This is just the way it works, and of course that's based on your browser's time zone, right? So when creating a date, I can pass in a string like that ISO date format, and if we look at it, we see that this is 1600 hours, and that's GMT or UTC Zulu, and so we would expect it to knock off about 5 hours depending on if we're in daylight savings time or not. And so when I run this, we go from 1600 hours to 1100 hours, and that makes sense. We expected that conversion. But oftentimes, if this Z is not included, if I knock that off, it's sometimes assumed that this is then a local time zone and would be treated as such, and thus we wouldn't get any time zone conversion. But when I run this, we get exactly what we got before, which is converted. So this is important, especially if your database is not in GMT or UTC. And so let me start this back up, and I'll walk you through how you can check that. There's a query here, select DB time zone from dual. That's the easiest way to figure out what your database time zone is. If you are GMT or UTC and you're storing data in standard Oracle dates, you should be fine. When you get the right date format and the ISO format, they should convert just fine at the browser level. However, if you're not GMT or UTC, then you'll need to do some kind of conversion almost certainly. And so here's an example of how you could do that. This being Oracle with so many different options, I'm sure there are other ways to do it. But the basic gist of it is that we use cast, and we're casting hire date, in this case from employees. Hire date is just a very simple date type. So we're casting that into a timestamp. And the reason we're doing that, even though we're not going to get the precision and fractional seconds that timestamp has to offer, what we can do is then use from TZ on a timestamp type to essentially add a time zone to that time, or rather, add a time zone to that timestamp. And so that's really important, and that allows us to do this next thing here, which is at time zone and specifying UTC. So of course, in this case, I'm assuming that when the query above was run, select DB time zone from dual, I got back US Eastern. And if that's the case, this is the time zone you would use. If you got another time zone, that's the one you would want to use. And then you can convert that to the appropriate time zone after the fact. And finally, just a quick plug for our Oracle University. If you are considering any hands-on training, whether that's in class or online, please check out education.oracle.com, where you'll find a variety of new subscription-based learning services. Of course, there are also a number of certification programs that can help you validate your skills, and who knows, maybe even help you get that raise you've been looking for. All right, good luck. Thank you very much.